I think it's easier if I try to explain what it is you're doing and why you're doing it. We're leading up to integrals, which is finding the area under the curve. And when we do that, we have to use a derivative and an antiderivative. So the first two things we're doing are derivatives and then antiderivatives, and then we'll do some integrals, okay? So, if f of x equals x squared, f prime of x is one of the notations you can use. It is the derivative of x squared is 2x. And I'll explain that on the next page of how I got the 2x, but don't worry about that right now. What we're doing is we're saying, what is the slope of the line at different parts of this curve? Well, we know that the slope right here is going to be different than the slope right here or the slope over here. Okay? Let me do that a little bit better. So what we do is we take the derivative, and at 0, we plug in a 0 into that derivative, and we get that the slope is 0, which it is. It's a flat line. And over here on the right, we plug in a 3, and the slope would be 6, which we know that slope is positive. So the slope on the right side would be 6. And then the slope on the left side, if we plug in a -2, we'll get a -4. So this slope over here is -4. And as you can see, the slope changes as you go around the curve because we're dealing with curve. When I got my pool was a very odd shape. When they left, they said, here's your pool, we're done. I said, how many gallons of water are in the pool? You need to know how many gallons of water are in a pool so you know how many chemicals to put in when the pool is low on chemicals or high on chemicals or whatever. And they said, we don't know. And so my son and I went outside and we measured. It was a very odd shape, kind of like a cement pond like this. And we measured the length. If we had had the equation of that curve up there, we would have been able to find the area under the curve using integrals and the area under this curve down here using integrals, and then we just would multiply that area, that total area, by the average depth of the pool, which was easy to do because it went from 4.5 to 6.5 feet. So, but we didn't have that information, so we had to do it differently. But with calculus, you can find the actual area under a curvy line. Okay, so let's go and find out how to do derivatives. So this is a linear equation. So we've got 2x minus 4. And I'm going to do two things. I'm going to add a 1 exponent to that x, because that's what it is. It's x to the 1. And I'm going to add an x to the 0 here. And then you can see what we do to find the derivative. You multiply this exponent by that number. And then you reduce that exponent by 1 because you used them to multiply by that number. So now it's going to be times x to the 0. And what is 0 times -4? It's 0. So the derivative of that equation is 2x to the 0, which is 2. It's a plain number. We're going to do 2 more. So don't worry, keep looking at these to see. So the next one is going to be 4x to the squared plus 5x to the 0. Whenever you have an x to the 0, that number is going to go away because when you multiply 0 by 5. So here you've got 4 times 2 is 8. Now you reduce this by 1, so it turns into an x. And this guy's going to bite the dust. So it's just going to be 8x is going to be your derivative. This next one is 4x squared plus 4x plus 4x to the 0. I'm going to put a 1 here. 2 times 4 is 8. That x turns to x to the 1. 4 times 1 is 4. And that changes to x to the 0, which is a plain 4. And the last guy bites the dust. Look at this a couple times. It's only a minute and a half. And make sure you get these right because we've got to do antiderivatives tomorrow, which are a little harder. Now let's look at this one. This one looks a little bit harder. My program doesn't give you really hard ones, but I want you to know how to do these. So you've got I'm going to add an x to the 0 there and an x to the 1 on that x. What is 4 times 1/2 is 2. The x is reduced by 3, by 1, so it goes to 3. And 3 times 3 is 9. The x is reduced by 1 is 2. And then 2 times 2, negative 2 is negative 4. And the x is reduced by 1. And then this one is plus 4. And then that bites the dust. So that would be the derivative of the guy above it.